Title of our project is Gesture Designated and Voice Control Robotic Hand Using Myograph Sensors. I, Raghav Prathak, represent you my team members Bhavya Shah, Abhinav Lakhani and Mohit Balala. We are mentored by Professor V.D. Patel and our college is UV Patel College of Engineering, Ganpat University.
Okay, so now the idea description. We have used gesture to designate the various activities that we need our robotic hand to get performed. Thus, it will learn using our gesture designation. Also, we have used the tactile sensors on our finger surfaces, which will enable the touching and non-touching effects of our robotic hand to various objects. We have used Amazon Alexa to perform the activity of voice controlling through the Amazon Alexa and creating a virtual LAN type network that will be available locally in our Raspberry Pi. Our robotic hand has got 7 degrees of freedom once it is completely made up and it has got its full length covered. Also, we have enabled the use of neural network in our system for the machine learning aspect. We have added 2 layers in our robotic hand to get the accuracy of about 75 to 80% while our performance. Giving the various descriptions of our parts. This is our fingers which we have used. Now, as you can see here, this is our 3D printed flexible material finger. There are no joints in this finger and it can bend like this according to the shape of various objects. Moving forward, this is the stepper motor which we have used. This stepper motor is having a length of approx 15 centimeter including the shaft. So it has got a very small size and it has got a torque of 0.8 kgcm. So we have used it here to give the various gripping and ungripping forces required to catch and detach our objects. We have used Arduino Uno for our various command giving operations in our project to the robotic hand. We have used this Raspberry Pi to perform the processing and also act as the brain of our project. This is the 3D printed portion of our palm in our robotic hand. Also, we have used the software of Amazon Alexa, which is available online and it is on the site of Amazon Alexa developer to give the voice inputs. We have used the Arduino library and its software to give the Arduino programming. We have used Python to do the programming in Raspberry Pi. Also, we have used the SolidWorks to perform the complete modeling portion of our 3D object, and the files of our modeling software and its images have already been sent in the documentation previously. We have used Microsoft Kinect to obtain the shape and 3D size of our object so that we can know which shape object we need to perform the operation on. The Microsoft Kinect has been used for this purpose. The Microsoft Kinect visualizes the object kept in front of it. It acts as a human eye and according to that it generates a 3D image of the object as well as it calculates the depth of the object surface and according to that it gives command to the Raspberry Pi so that these entry values will be calculated by the Raspberry Pi and according to that it will give the command to our robotic hand to perform the gesture and to grab that object according to the depth sensed by the Microsoft Kinect. Okay, so the left hand side of our screen shows the Python program which is used for data acquisition and getting the various EMG sensor gesture values for our robotic hand which it needs to learn. All of these values will be saved in the form of a text file which will contain the various numeric inputs of our gestures in the form of numeric inputs. Also, using these numeric inputs, we can generate a graph as shown in the right hand side bottom of our screen which shows the graph activity of our robotic hand. These numeric values will be taken as data in our MATLAB program which is shown in the center of our screen which will process it, configure it and according to that it will generate a matrix of 1 cross 6 to 1 cross 11 which will work as an input for our robotic hand once it has learned the gesture which it needs to perform. Now once all of this has been opened in our robotic hand, we need to give the voice command using the Amazon Alexa according to which our robotic hand will perform the gestures as commanded.
Alexa, start robot.
gesture controlled and voice designated mechatronic hand using electromyograph sensor. Tell me what to do.
Grab.
The hand has been closed.
Release.
Gesture recognition. The hand has been opened. Now what do you want me to do?
Grab.
The hand has been closed. Now what do you want me to do?
Release.
The hand has been opened. Now
The-
what do you want me to do?
The silver foil on the surface of our fingers is the use of tactile sensors. This is our tactile sensor, and using this tactile sensor we have given each tactile sensor pin a surface of our finger, so that any two of our finger surfaces, when touched by any of the metallic body or metallic object, then the fingers will stop and it will grab any specific object. Okay, so the challenge is faced. Due to the imperfections in mechanical fabrications and assembly, the overall system of robotic hand doesn't work as efficient as it should be. Second one, due to the unavailability of the exact 3D printing flexible material that we need in our system, we have used another optional 3D printing flexible material, so the exact bending is not obtained of the fingers. Third one, due to the presence of power line noise in our EMG sensors, which is not filterable, we recommend the use of external source of power like battery. Fourth one, each time we reboot our complete system, it takes time in the interfacing and recalibration of our whole robotic hand system. Okay. So the implementation of all the features that we had enlisted in our documentation has been successfully completed and worked out on our robotic hand up to its portion of palm. Now we need to expand the same features to use them and to calibrate them for the remaining portion of our forearm and shoulder using the same functions, and to carry out the whole performance of our robotic hand in a simple manner using the DH parameters and the kinematic model of our robotic hand, which we have already made. The cost estimations in Indian currency are EMG sensors 4,000, tactile sensors 1,000, motors for 4,000, 3D printed parts 4,500, miscellaneous components 300, mechanical components 200, and the Arduino and Pi cost around up to 2,000. Also, the overall cost goes to 18,500, and the making of full-length complete robotic hand can cost up to 40,000 to 45,000 approximately. Our day-to-day life requires us to use our human hand for numerous times. Due to this reason, various researchers and institutions have been trying to replicate the human hand. However, no one has been successful for the subject in 100% accuracy. We think that proper designing, application, and applying higher accuracy standards to our system and our robotic hand can result into bringing us one step further in this research subject, making it possible to enable the use of robotic hand in various sectors. Also, the reason behind this is that our robotic hand and its system uses various features and systems bounded together, and thus synchronizing and calibrating them together, making its functioning highly versatile, flexible, and dexterous.